Welcome back. In this video we're gonna see how the VXwheel 4 is assembled. Back to the frame. This is the rear battery part and this is the front controller part. In this design the rails and those box parts cannot go together, meaning the rails are part of the box. All of those parts, if you want it to be watertight, you need to use some silicone on the edge, apply it, screw all those screws, and then this is basically gonna be a one single part that is not meant to go apart anymore. You should be still able to take it apart by taking all screws out, forcing it apart and cleaning all the silicone, just in case if you ever need it. But I don't see a reason why you would ever want to take these parts apart. We need to make sure all the charging ports, switch holes, cable glands, everything is watertight. Only this way this is gonna be an awesome project. You can see some awesome things. For example, the footpad threads being right here are closed. Same with the bottom one, same on this side, because the footpad screw is one of the weak points of the VXwheel 3 design, where the water can go through the thread inside the box. It cannot go here because it's all blocked. Every thread is closed except for those that are going to be siliconed. So let's go assemble this. Cable glands usually have an O-ring, so they do not require any silicone. I'm going to just use some thread locker. This should be fine. It's M20 with 1.5 millimeter thread. This should be good to go. This is for the battery box. This is for the controller box. I'm using two cable glands. I'm not using any motor connector. There are plenty of reasons why I'm not using the connector. There are also some reasons why I would love to use the connector, but I'm probably gonna explain this in details in a separate video. Now I'm just gonna use the cable glands. Did I say no 3D printed parts in this build? Well, almost no 3D printed parts, but these are just battery holders to keep batteries in place. In the next version this should have a place for it to sit exactly on the spot. Here I'm gonna just glue it manually. This is battery number 1, goes here. Battery number 3 goes here. There you have it. You see the spots where this needs to be. Same with the front, like this. So those should be just glued with small dots of silicone. It's just easier to clamp it now than later with the box assembled, but you can totally also do it later. There you have it, the rear one. This one's gonna use really little of the glue. I'm using the Speak-on charging connector. It's placed here in the back because there's space here and there's not much space in the front, but still the battery is here pretty close. So the best way is to solder the wires out on the 90 degrees, going out like this, and clip those pins in half, because you don't need all of it. You can solder on this part and clip the rest away, and it's gonna be all good and it's gonna fit in its slot. I sealed it a bit with liquid rubber because it's easier than putting shrink tube on 90 degrees contacts. I didn't want to use those two mounting holes and have screws exposed on the outside of the rail, as I'm, for example, having here, because it's just better to do it the other way, and that is by placing the connector in its slot and using this kind of thing and two screws to hold it in place. Plus you absolutely want to silicone this edge because you want to have the enclosure completely watertight. So let's do it. Two things about switches. I couldn't fit the light switch into this part just because it's milled and it's different processing as 3D printing. So even if I wanted to have it in the handle as I have it in my previous design, it was way easier to put it in the rails. So I have now switches in both left and right rail. If you absolutely don't want the second hole in the rails for the light switch, let me know and I'm gonna make sure to order some rails with no hole on one of the rails, or you can just seal it off or use it for some other features. It's totally up to you. I use it for the light switch. Second thing about the switch, if you're using the Tronic 250L, I noticed it has a different switch port than the little focal that I used before that was on by default. This one is off by default, so it needs close contact to work. Just wire the switch differently, and that's about it. I'm gonna mount the switches and then I'm gonna assemble the rails together, and then we're gonna do a very cool test. Same as with the charging port, this hole needs to be completely sealed, so either use the O-ring that's usually supplied with the 90mm switch or use the silicone on the edge. It's totally up to you, just make sure you're doing it 100% sealed. Now it's time to assemble those parts together. As probably already mentioned, those boxes come together with the rails and must be assembled as one part, all sealed up. We'll use some silicone and a lot of tiny screws, and this should basically become one piece at the end. Why is it made from more pieces? Because milling complicated parts from one big piece would cost even more and would make things even more complicated. Anyway, the side of the box is basically the rail, so there would be no way to mill it from one part. I'm gonna start with this one, going right here. It fits very nicely with a lot of screws. While the first and the last screw can be longer, that's M2.5, 6mm long. The rest on this one are M2.5, only 4 in length. They can be hard to get, but if you ordered the kit from me, you should have them. I prefer to use more screws and tiny ones than a few big ones. It's better to seal this thing properly. It's M2.5, so don't make them too tight or you're gonna break the threads. Because it's a very tight spot and it's pressed one towards the other very nicely, you can see I used very little silicone, but still a lot of it got out. Clean it away and it's gonna look perfect by now. Here's the reason why you should not use longer screws here, because they pretty much end up in the battery. So 2.5, 4 long, not any longer. Let's clean this up and see what we got. It should look quite perfect on both sides. This side I'm gonna use M2.5 screws, but normal head ones. We can make it more evenly spread with a knife. Again, tied them up quite well, but not too much. All good, ready to clean up this mess. That's a very nice box. Now we have to do the same with the front box. This one goes up here, it's just different angle, screwed from the bottom, not from the side. And this one goes on top here. This one's very nicely done. Let's do this as well. Now we're gonna implement this into the rails. Even if it looks complicated, the next step is pretty much the same as the ones now, because this perfectly slides into the spot, same as the front one. It slides perfectly into the spot. It's held together by this screw on top, this screw right here on the side, quite a few of them in the bottom. Those are M3, those are M2.5. I'm gonna write down the length as well. All you have to do is take care to seal all of this gap up. It's easier if I show it here. You have to seal this line and this all the way up. That's it. One important thing not to forget, the first rail can be done one box by one box, so you can practice and see how things go. But the other rail must go basically at the same time to both boxes, because the rail slides on from the side, so you have to do one first with both boxes and then the other from the other side. One rail is on, looks amazing, everything fits exactly as I want it. There you have it, all in one piece. Went together amazing. Everything's nice. Everything's sealed. Now to the fun part. I've blocked this cable gland with a screw head. I think it's watertight. I've covered the connector just because I don't want to ruin it, but it's mounted watertight for sure. That's to answer the question to many people that were asking me, how is this build gonna be with water? And I think it's gonna be pretty much the same as every other build. The better you seal it, the better it is. I think it should be fine, but let's test it. The bumpers don't really matter here now. The light opening is sealed, I think. Everything should be sealed. We will only do the prototype gasket. That's all I'm gonna use. Not even glue it on top. And the foot pad with no grip tape yet, because I don't want to make everything wet. And we are of course doing this before any electronics are installed. We are even using less screws than normally, because the front two are missing now. They go into the bumper, yes, but they still help into making this pressed down as equally as possible. You can see the seal here and here and here and in the front. Now let's find out. Put this in water. Well, for the beginning it floats, but we're gonna press it into the water. There seems to be no bubbles coming out, hopefully. Can turn it the other way. Into the water again. And again from this side. You want anything more to be tested? Let me know. And again. And now let's find out. Looks all dry to me. Not a single drop of water inside. For me, this is test passed. Anyway, no onewheel is good for water. I don't recommend riding it in super wet conditions, but this is just to show you that an open top design is possible to make watertight or as close to it as possible. You just have to make a good job at sealing everything, and the better you do it, the more water resistant it's gonna be. That's pretty much it. I'm not saying it's impossible to get water inside. I'm just saying it's possible to make it very, very good and very, very resistant to wet conditions. So now I know the system can be good enough. Now what we don't know is how good I made the front box. I might do the front controller box, I'm not sure yet, because I need to seal the battery monitor first. About the battery voltage displays, which I usually have in the handle in all my builds, because it's a cool place to have them. Those normal ones will usually work until 100 volts. I tried to hook them up and above 100 they just show 100. This one, however, is rated until 120 volts, which is better, but it has a smaller display and less data on it. As for the not so good news, you still need to chop the rear part of it, of the housing, because it's just too thick. It's the same as in my previous design. I'm sorry about that, but if I would keep the whole housing of it, then the handle would just be too small. So I prefer to chop this away and have a nice handle as it should be. This is watertight, the front, so it's not a big deal. So we're gonna again seal everything around, install it in place like this. Okay, the display is installed. I sealed it from the bottom and from the top. Now it's open like this. It's pretty much flat. I left a hole in the footpad just so that the footpad doesn't press on the display itself too much. So I think this will stay. I will not delete this hole. The way how this is gonna go, this thing here is the front gasket. I didn't cut it yet. It's gonna cover the display, and since it's a piece of foam, it should protect it nicely. Right now we'll wait for this silicone to cure, and we'll do the front box water tightness test. I'm gonna use the rear footpad because the front one has the sensor on it. Switches are covered just in case. Controller box holes are covered. And I'm dipping this with the display, with everything as it is. It's nice to be back in the test spot. Don't look at the wet seal. Looks all dry to me. As for the banks compatibility, this is the front controller box. It has these two pieces sticking out a little bit to make room for the battery, and we need to mill this into the bank bumpers. I'm gonna make my day a little bit easier, and maybe also yours, by cutting this piece out of vinyl foil. We now have a sticker that is gonna show us where the bank bumpers need to be modified. Spray this with water so it can be positioned. Pretty much if you center it out and the holes are aligned, should be fine. Get the water away, leave it to dry just a little bit. Now you can either leave this on and mill these two pieces away, or just mark it. Okay, a few more words about banks. I'm designing a lot of custom parts. Wherever I see there's a potential to make things better. For bumpers, I think those are a pretty cool option. I've seen many other bumpers break easily. Those hold pretty well. So the rear one is compatible with the VXwheel 4 straight from the box. The front one needs these two spots to be milled down for 2 millimeters, which is not a lot, to accommodate those two spots. I could have put the battery packs above and easily get this extra 2 millimeters into the footpad, but since many will probably use different types of footpad, I figured out it's just better to change the bumper. Either use these or similar tools. You can get the 2 millimeters thickness with the BMS plate and just set the right. That should do it. with a sharp tool. It's not that big of a deal. It's done in 5 minutes, maybe 10. That's what you should get. It does fit perfectly. But don't mount the front bumper yet, because we must add the controller first inside and then seal these holes from the bottom and then put the bumper up. Just cut the gaskets. Now I'm cutting the grip tape. If you're ordering raw milled foot pads, this is approximately what you can expect. Just wood, no fancy things, with a sensor cutout, and that's it. But I'm gonna show you how to install the threads, and then you should definitely apply some clear coat to them. What you wanna do is hammer these kind of wood nuts in these slots. Take care they don't stick out. Try to fill the extra space above the nut with epoxy glue. The more tight it is in its space, the better. So I'm gonna do it like this and then sand off any excess epoxy that is left. I'm gonna show you the final result. This is approximately what you should expect. And with some sanding, they're now ready for the clear coat. I'm using 2-component polyurethane clear coat. I'm not saying this is the best or the only option. It's one of the good options. And it's good if it's UV resistant, but doesn't really matter. We're gonna wreck those soon. First layer of clear coat, a bit of sanding, and it's ready for the second and probably final layer. All nice and shiny. I think that's gonna be the last coat I'm gonna do. Next up, sensors and grip tape and stuff. The 2 foot pad reinforcement plates are of course flat, so we must bend them by aligning the middle of the gap on the edge of the table or something, and just forcing it down a little bit. Now it's probably about half of what we need, so a little bit more and it's gonna be fine. That's about right now. If you got this from me, this is from strong aluminum 6082, so you have to use quite some force to bend this edge, but then you get a nice result. If you're using a wooden foot pad, at this point you should place some dummy screws to align the holes. If you're using other types of foot pads, I found it possible to use double-sided tape over the whole surface of it, on the bottom of course, I mean in between the metal plate and the foot pad or things like that. But with wooden foot pads, screws here and then stickers above to cover it all, it works just well. With the screws installed, this should be it. Just missing the grip tape. So the front boot is the same, just with the exception of installing the sensor. I'm using the V3 stoked sensor. There's a hole for it here and here. It's basically all the same, just stick the sensor on it, screw the pads together, be extra cautious not to damage the sensor, not to have any sharp things below it, then put the grip tape on and we're good to go. I'm not gonna go into deep details about the BMS and wiring. Why? That's because the BMS units are changing and new versions are coming faster than I am able to develop new boards. I plan to mount my Inoid BMS on this plate. That being said, those spacers are going to be provided if you get this plate from me, and they go right here and right here, and they will act as BMS holders. So first you mount the spacers and the BMS to the plate, and once everything's done you just put the plate here and put 2 additional screws here, and the BMS should be in place. The whole aluminum plate BMS holder system, which is gonna be approximately like this, is not only to nicely hold the BMS in place, it's also to dissipate some heat from it, so it helps in both ways. With everything else done, I'm pretty much left with the wiring, and I'm doing the front to rear loom. It's a lot of wires, and it's not easy to fit, but it seems like what I'm trying to do will fit these cable glands. I'm probably gonna try to put all of this in a shrink tube as well. I'm not sure yet if I'm gonna succeed, but we have two main wires, only one charging wire because the charging port is here, so we just need the return positive in the front, and we have three signal wires. One's gonna be used for data communication with the BMS and the rear lights, two are gonna be used for the temperature sensors and battery pack 5 and 6 sense. There is, right now in this configuration, I have 3 times 6 wires. I have 2 tiny wires too many, but it's better to have 2 extra in case something comes up than to have less. I have a different type of cable with more thin wires, but more of them in case this will not fit. But I'm still trying to use those ones because it's a little bit longer, and the thicker the cable for the battery sense, the better. This is not gonna be easy to fit at all, but I'm gonna try. If not, we can still either change one of the cables or use the wire mesh, which I used in my previous build, but I think the shrink tube will hold up water better with this. With the wire mesh, the waters can still go in and maybe through the cables, I don't know. I'm just thinking this might be better. Looks like it's gonna be possible to fit. If you wanna be anywhere close to succeeding at this kind of cable loom, you must be absolutely sure there are no wires crossing each other in the loom here, because otherwise it's just not gonna work. I'm gonna try to finish this. The next challenge is gonna be here. I left a little bit of additional gap here, so hopefully it's gonna be fine. I can't film this, it's a nightmare to do, but we love challenges, and that's just one of them. And now to the absolute most fun part of it, tightening this up in basically no space around it. Let's not even mention the gap for the fender. This is gonna be a nightmare, but this is why we develop custom tools. Option 1, a standard tool, sanded pretty much to the end. Option 2, a custom tool that I made, which fits amazingly. This one made the job better for sure. This one is perfect and looks very nice, but it's just not strong enough. I think there is absolutely no way any water can pass through here because it's so tight. Next, it's a cable holder. You can either 3D print them and insert a M3 nut here and just put it in place, or you can get the aluminum ones. Those are not cheap. I don't know why it's such a small piece, but I'm gonna see if I can get a better price. And it's pink just because I wanted to test different types of anodization. Gonna install this and move on towards the front box. Looks like it's just gonna fit, but I had to try with the motor mount before I fix the cable glands and everything 100% in place. I think I have used 110% of the cable space, but it works and I'm happy with it. Everything is fine. Just a annoying job to do. I'm trying to mount the LED lights with this super thin double-sided tape. This was not an option on the 3D printed housing, while this one is now flat and should be good enough. I think this way of mounting lights will be just fine, while I'm gonna cover them here with some tape because this is still exposed and you don't want to short it with some wire, so I'm gonna just protect it. Slowly doing the wiring. It's a lot of work with wires, it's going slow, but it's fun. I just can't show you each wire where it goes because it would be too long to film, but basically there are 3 data wires. One is going to be for one battery box, second one here is going to be for a second battery box, third one goes to CAN and 5 volts to the BMS, goes right here. The two wires that are left are for lights, going right here to those rear lights. I put the DC converter right here in a shrink tube and in a Velcro. I'm gonna do the same on this side, putting my light switch on a Velcro right here, just finishing the connections of it. It's connected with the separate light switch. It's gonna power also the battery voltage display. And yeah, let's move on and let's tight these things, make it nice. One thing about the controller mount, this currently fits Tronic 250R only, or the little Fokker if you're not gonna be 100 volts. Since Tronic announced they may change the position of the capacitors, I'm gonna change this plate to be flat all the way to the end without this hole, and therefore if you get a different controller you can drill your own holes. I think that's the best approach I can do right now, because people are changing controllers faster than we can adapt to them, so it's gonna fit this one, while possibly you're gonna need to change this. I don't know about that. Maybe in the future I'm gonna add holes for different controllers, or just offer this part in different shapes. Make sure you do double isolation. I used Kapton tape on the fats, and I'm gonna use the thermal gap filler right now. Don't install bumpers before you install your controller. You do wanna cover these holes in the bottom to make them sealed. Okay, the controller is in position. Don't forget to use fiber washers or some isolating washers here under the screws. And I used some Loctite as well. I'm gonna take a piece of vinyl foil, which I can provide for you as well. Just put this sticker here. Now we can install bank bumpers. For each you need those gaps milled that I explained before, I think. By the way, those threads in the rails are all M5 if you're getting the rails from me, so don't use standard bank screws. I will provide you with different screws for that, because I'm doing it all metric. Sorry about that. There you have it. Bank bumpers fit nicely. So this is not gonna be the same, because I'm gonna leave this for any bigger controllers. Get locked in place like this. It's a nice cover just to protect the controller. We can make a similar approach even with no hole here. I'm just gonna stick to this surface, not to the bottom one. It's gonna be fine. Now let's wire this up. There are several things I found on the way that would be nice to discuss. For example, this screw is for the bumpers, this screw is from the footpad. In some designs of other builders, they use it the same, so that the footpad goes through here and screws into the bumper. So if you're using different footpads, you can just ignore this hole and use this hole. It's totally up to you. I'm just explaining what the options are. I get a lot of questions about how I do my wiring. That's gonna be pack number 1 with a temp sensor as well, and then we're gonna move forward to the next one. It's gonna get this and this at the end. I don't remember if I explained it already. I used through-hole fuses on the BMS connectors in my last build. Now I'm using SMD fuses, because there's just better being a one piece holding together to the connector, while the small through-hole fuses that I soldered one by one, which you could see in my previous videos, were a little bit fragile to break off from the connector. So this is a way better approach. And you have these little slots here to put a shrink tube above each cable first and then above everything together. It's an improvement that I think it will save some troubles. Why do I use fuses on the balance wires? This is for extra safety, and I think it's kind of needed, because if some of the wires break or the wiring breaks here or whatever happens, the battery has a lot of power and going through the thin wires, if they get shorted somewhere on the way or anywhere, that will create a big damage. So I think those are important, even if many people would not really suggest using fuses on the BMS wiring. So that's, for example, cable for battery pack number 1. As you can see, the temperature sensors go directly to the connector, the balance wires go to the fuse board, and they're now going to be shrink tubed, and that's about how I plan to do it. The next one would then be with the first pin off, and then 4 wires, and this is how it's going to continue to the very last one. Well, the last one is going to have the temp sensor again, so another 2 wires. So that's about how the first 3 packs wiring loom would look like for an anoid BMS. The 4th pack will go from the next connector, which will connect also to the packs in the front, so that one's gonna be different, but that's about it. There's a lot I could say about the whole cable gland versus connector thing. I initially wanted to use the connector, then I decided not to because it was unavailable for too long, and it got me thinking that why would I even use it. So let's face it, what's better? Cable gland is better in every single way except for not being so easy to take in and out, but in everything else it's better. There is nothing wrong with using the cable gland, or so to say, it's the best solution, but it's a little bit more tricky to use. Let's install the motor and let's explain why it is actually not that big of a deal to use the cable gland. It all comes down to using the right tools for the right job. So even if I would fancy the connector here, sometimes when changing the tire or something, I'm sure there are more benefits to not using it than to using it. Why is a cable gland a problem? Just because it's in a tight spot and it's not easy reachable. So how would I fix it here? It's even rubbing in the tire right now because I put the air out. Well, to get to the end of this, I'm gonna first install the cable exactly in the place where it needs to be. This is the high-speed version 1, which is the short cable, and the overall isolation ends just here, so it's just right, so I don't need to extend it, but I am gonna need to extend the whole sensor wire, and I'm not gonna need to extend those. The cable should now be in the right place. This won't change anything right now, so I'm gonna install it later. Now we can install the inner part of the cable gland first. Up to this point there's absolutely nothing that is more tricky than using the connector. When that's in place, you just put the nut in place. There we go, the cable is installed. The only thing that is actually tricky is how to tighten this up, because it's just not easy accessible. So the solution to all of our problems is just a custom tool to make this job easy. You need to have absolutely no air in your tire for this job to be doable. This is why we have this tool that I just grinded off a normal tool. Even if it's thin at the edges, it's very, very strong. I couldn't break it till now. So, with a deflated tire, this is not a problem at all. It's just a slow process. Take a few minutes, do it step by step, and little by little our cable gland is gonna be in place. And if this takes a few minutes extra towards using the connector, but is way better in handling high currents, then I'm definitely happy with this solution being used. It's just a few minutes more of your time. Whole sensor wires need to be extended by about 10 centimeters if you're using the V1 high-speed motor. So it's gonna go about this way. I soldered those and I'm gonna recream it at the end. It's not a big deal, just some extra work. If you hate crimping wires, I'm sorry, there's quite some crimping to do. I found this crimp tool to work the best from the cheap ones. So this one is not expensive at all and it works quite great. There are also better ones available but cost way more. So I'm happy with this one for this amount of work. Since the phase wire connectors are not the same, there's either the option 1 to change those for the smaller ones or change those for the bigger ones. I'm gonna stick with the ones with the controller because they are just better ones, so why would we make them smaller if we can make them bigger and more current resistant? The only reason why I would make them smaller would be lack of space, which yes, I am lacking space in this box, but I'm gonna fit it somehow and it should work. The front box is now almost wired, not completely nice yet, but it's gonna be. I installed the fuse here right after the main positive from the 6th box. This goes to the BMS in the back. This is the main positive that will go here. There's space left here. I don't need this space right now. And there is a little bit space here, but this will be used by the connectors. Do I like this connector? Yes, because it has an anti-spark on it. Do I hate it? Yes, because it's huge and I have no idea how to pack it in here with the other one. I shortened those two cables, the main ones for this, just a little bit. I also shortened the back kinda cable gland of it a little bit. So I'm gonna try to squeeze them like this in this spot. It's not much space, but hopefully it's gonna be okay. A few things about the rear box, which is pretty much done. The cables are disconnected right now because I'm still working in the front, but this is pretty much it. There's some gap here. The battery is about 4 millimeters under this top edge, plus there's gonna be the seal, which is 2 millimeters, but when it's squeezed, it's, let's say it's 1. So it's about 5 millimeters of gap between here and the lid. I could raise the battery, but the lower it sits for the center of gravity, the better. This creates a gap to the lid, and you don't want these packs to be jumping up and down. This is why I'm installing some foam like this. It's a bit too thick, but it's quite soft, so it's gonna squeeze. Everything is gonna close up pretty nicely, as you can see, and the packs are gonna be pushed down a little bit so they stay in place. Second thing about the foot pads, if you make them the same way I do them, I cover these things and the screw heads with foil. I'm gonna include those in the kit so any of the screws can't get out with the vibrations. Plus, if any water gets in between the foot pad and the aluminum lid, it won't just dip out here. It's just an extra feature that I like to use. That's the gap I'm getting if I'm using 10mm foam, plus like 1mm is gonna be taken from the seal. So squeezing this down is actually not too bad at all. In front the situation is different because these packs are pretty much aligned. I'm gonna fix this mess and then basically everything's done. That's about how I installed the seal with the double-sided tape. It's gonna go like this. I try to put it on the inside, even if the holes need to be cleaned out later, just for extra safety. The water can't go through in the box, but it can go sideways if it's not sealed here. If you want to hear about some tricks, I use some plastic screws with the chopped head away. So when you have this exposed and it's gonna be sticky, it's easier to align. Pulling them over the screws and slowly pushing it down in place. Some details I don't remember if I showed. Those connectors are pretty close to this rail, so I covered the rail with Kapton tape just in case if you take this whole BMS out that you don't touch something with the cables. Well, now it feels like it's basically done. That's about how I fixed the sensor cable and seal those holes. There is not much space here, but right enough for this. This is why I want this cable to go out a little bit in front, not just here out, because there is nowhere to go right here, so it's going to be better that it goes out like this. That's about how you build your VXwheel 4. I hope you enjoyed. Here you can see the finished front box and the rear box. I even shortened the phase wire cables from the controller to make it all nicer. The kits of parts are now available, so get yours and see you soon.